at Microsoft R&D Center, Nerd Center. But hopefully after COVID days, we'll come back to those days again. So let's get started and what we're talking about today. On today's meetup, we're going to talk about something called Pytest, which is a testing framework. If you're writing software, you have to have all these, automated test code, which will verify the functionality and maintain the backward compatibilities and all those good stuff, and make sure that things are not buggy. And technically, it's a default thing. Like if you're writing enterprise software, if you're building something that has to be maintained for a long time, you need to write the test. Now, when you're writing Python software, the one default testing framework that Python language provides is called Unittest. And in our last meetup, we talked about Unittest, and we touched about how to play with the unit test, and how to write the unit test using that unit test framework, and some of the drawback of that framework. Today we're going to talk about the another one, which is like on top of unit test, a better one called Pytest. So this is again another framework which provide you much more functionality, more powerful when you want to write the test for your Python software. So let's get started and talk more about it step by step. So we'll do some introduction. We'll talk about the core functionality of Pytest and some of the concepts around Pytest, and then we'll go into demo. Maybe what I will do is, as we go through the presentations and as we discuss different kind of ideas around Pytest, we'll also parallel run the code and see by ourselves. So it's always good to see the things in work, and finally we'll talk about the conclusion. Okay, so let's talk about Pytest first. So what is Pytest? So Python already has a unit test as an automated testing framework, and Pytest is a better version, or unit test on steroid, you can say that. Pytest doesn't come bundled with the default Python installation, so you have to install Pytest manually. It's a powerful and it has more capabilities. So this is something I like to always talk about. So when I say something is more powerful, what do you mean by powerful? Powerful mean that certain things that you are not able to do, you are able to do that. When two things, you're comparing power for two things, you say that the thing which is less powerful has less capabilities, things has more powerful have more capabilities. That means more things that you can accomplish with the more powerful things. So in that sense, Pytest is more powerful because it has more capabilities when you're writing test, and these more capabilities allow you to write test better, faster, and less code to achieve the same thing. So that's why Pytest are better than unit test. You'll see more during the example how when we'll compare unit test and Pytest. And right now, if you are talking about enterprise software built on Python, Pytest is far most popular automated testing framework than any other right now available. There is something called Nose. There is something called, of course, default unit test, and which was the other one? There are a couple of other them, but Pytest has been like the clear-cut winner right now in the industry, a de facto testing framework that people use there. So that's the Pytest. Now, so just touching around again, like why Pytest? So I've been talking about this, that we have unit tests, but why we need another testing framework when we had unit tests? What was the inspiration behind bringing the Pytest? So first thing, I'll just brush up what is unit test is. And we'll see, I'll just refresh the unit test. So it will be better to compare unit test with Pytest. So first thing, Unittest came out as a testing framework with Python. It actually was independent framework, then merged into Python, and it was much more inspired by JUnit, which is a Java-based testing framework. And a lot of the inspiration and a lot of things were written in parallel to Java. So the thing is, the unit test library itself is written with certain methodology, certain design pattern, which were parallel to Java, because it was inspired by JUnit. So it was not really Pythonic way or Pythonically designed testing framework. It was more like a JUnit based design, but we are writing the whole thing in Python. So starting with that, that was first thing. And because Java is completely object-oriented, or maybe almost object-oriented programming language. So everything that you write in your unit test every testing that you write using unit test has to be wrapped around a class, and there is a solid structure, a lot of boilerplate code that goes in that, and that is all like bad thing here. Why we don't want to do the unit test, because the philosophy of the Python has been like do more with the less code. So just to bring in that, I'm just gonna bring in a small example that we did last time, just to highlight some of the things that so this is our typical unit test look like. You import unit test, you write the class. Inside the class you say you inherit the unit test.test. So with this inheritance, it brings all the testing functionalities, and then for each test you write the test, and then use those assert statement which are derived from unit test class, and then you write, basically you write the assert statements, and assert equal, there are two parameters where you test different things. You normally give the method, and then you see the response and check whether method give you same response or not. And basically and for each of them you have to do that, and finally you do unit test.main if you want to run directly, or you have to do python dash and unit test to run the test. So few things. So if you see here, if you let's say you are just writing some kind of function, some kind of method without any class. It doesn't require any class, just some random module, but you have to wrap it around some kind of class, because that's how unit tests work, that it has to be around class, and that class has to have this kind of unit test structure. So this is the kind of boilerplate that you always have to write. uh, let's see if we have example of and okay, one more thing was something called test setup and test teardown. Hmm, sorry. So if you see here, so test setup and test teardown. So every time, so the idea is that you want to write a function, and you want to have some kind of functionality where you want to set up something before the test run, and you want to like execute something once test is done. So every time you run test title, or all those test title, all these two tests, the first thing it executes is test setup, then run your test title, and then your tear down. Again, for running this test is old card. It first run the test setup, then run this whole code and tear down. So every time, for every test that you're running here, because you wanted to like separate out setup and tear down, it will run for all of them. So this is the kind of structure that is being used by unit test, and it has some kind of rigidity, like why I have to run the whole thing all the time. If I can set up the one parameter one time, I don't need to run the setup and teardown every time I need to run the test. So if I have 50 tests, the setup teardown will run 50 times. I don't need them to run 50 times. I can have them run only one time, and also have an option to run them 50 times based on my requirement, and then run the test for each of them. So a lot of rigidity is here with the unit test, and because of that, we needed something which is much more flexible and much more powerful in terms of capabilities and functionality. So that's why we need Pytest. Uh, and again, like we can, with the Pytest, we can use standard Python assertion statement. Python also already come with the assert statement, and it raises assert error if something doesn't match equal to true, doesn't come out. And so we don't need to use those custom self dot assert statement coming out of inheritance. Uh, Second thing is with the Pytest, you also provide a lot of powerful command line tools. So when you're running Pytest, let's say you don't want to run the all tests, you just want to run 3 tests or 2 tests or 1 test. You can do all that with the Pytest. You can filter the test. You can run custom tests. You don't need to run the whole thing. That is not possible with the Unittest. In Unittest, you kind of run whole thing. Uh, and again, Pytest also has a huge community out there. So there is always support and maintenance going on there. So just wrap the whole thing around why we need Pytest. First thing, we need a testing framework which is much more Pythonic and away from whole Java world, and the Pythonic way of writing test. Second thing, we don't need read structure. Third thing, we don't need any kind of boilerplate code, and we can use some of the more functionalities that is not available. So these are all reasons why the Pytest was invented, and what was the major selling point of using Pytest. Now let's talk about a couple of features of Pytest that we're gonna execute here and see around them. So first thing is parameterizing. Now, why parameterizing? Parameterizing is the idea that, let's say you want to test some methods and you want to test them on different input and output. Like, let's say add method, I want to check whether it behave properly when I'm adding two negative number, when it is working properly when I'm adding two positive numbers, and result is coming out well. So if you look at our older method here, how we used to do that. For each condition, we had to write separate self statement. So instead of that, with the parameterize, you can just say the parameter and you say these are all my set of inputs and these are all the expected set of outputs, and you just call it once and then method automatically call them. So this is called parameterizing. So basically you are there's a method and you parameterize the method, and method will automatically take one by one parameter, input output, and test your code and tell you that, hey, it ran perfectly on all parameters or none of them, or wherever it fails. This will make more sense as we look at the example, so stick with that. So first thing is parameterizing. Second thing is fixture. Fixture is very, very important concept, and it is majorly used in Pytest. So why we need what fixtures are? Fixtures are basically way to, so we saw the test setup and test teardown. It is something similar to that. You want to run some test, and before running that test, you want to set up some kind of environment scenario. Let's say you want to test, there's this huge app, and you want to test that this user has access to run this feature. So before you test all those things, you have to first, in your test, you have to create the account, you have to create the user, you have to create user permission, and then you have to actually run the test. So all that preparation part where you create the project, create the user account, and all those boilerplate work that you have to do, you can do it once, and then in all your tests you can just call the fixture, and it will just use that fixture as a baseline, as a minimal setup. And after that you can run all kind of tests like, hey, can user do this, can user do that, can user do that, and all kind of scenario that you can run on the user. So with the fixture you can create certain environments, you can create certain kind of setup, and then you can run them. Now fixture is much more like test setup, but with the fixture there are a lot of other functionality that you can do that. One of them that we'll see is a scope, where you can figure out that, hey, I want to create this whole project, this whole user setup for either running my all test suite, or running this single function, or running this single file, single module, single package. So on different scope level, you can create the fixture and see what is the lifetime of that fixture. So that allows you to like sometimes also reduce the cost or reduce the runtime of the certain functionality. You don't want to like, hey, I want to verify that this user can trigger the feature 1 and feature 2, so I don't have to create the project and user and everything every time I have to check this functionality. I can just create one time and then run all the tests on that created user, and then finish the test. So a lot of those advantage we have with the fixtures. Third thing is selected test. So let's say you have this one file which has, let's say, 50 tests, but you only want to run a couple of tests. You can do that with the Pytest. Just say that, hey, filter and only run this test. There are way to group the testing also. So let's say there's a way to like tag all the tests in with certain group, and then you can only run certain group. Let's say you have two features, and for unfortunately you wrote all the tests in single file. You only want to run the group 1 test, not group 2 test, or feature 1 test, not feature 2 test. You can put them in single group and run them. So the idea is you can selectively pick the test or group of tests and run them. You don't have to run the whole test suite for the purpose. When like there's a verbose mode, so there's a lot of debugging information that is being thrown out, and there are a lot of other plugin functionalities out there. So let's say you want to extend the Pytest functionalities, you want to make it work for different kind of framework, you want to create the testing report, coverage report, and all those kind of things. You can do that by installing extra functionality, extra plugins with the Pytest, basically extra library on top of Pytest. So all that is possible with the Pytest. Now let's look at the first example of how to write the Pytest. So Pytest is just like anything else. You just write the function. There is no, if you see here, there is no boilerplate here. There is no test, unit test, any of that. You just write def test. Also, there is only one requirement, that your name has to, your function, the testing function has to start the test. That is a requirement in Unittest also. That is a requirement in Pytest also. And also Pytest do the discovery of the testing function. So This is this is one thing that you must do, that all your testing functions should start with test, then test underscore, and then you write all those things. This is not standard practices, this is the requirement. And then you can do the assert. This is a standard assert statement that comes in the Python. So let's get into that. Where is my okay? So let's create the testing here. Pytest test. Okay. Let me. So first thing first, we need to create the Pytest is a library that we need to install separately. So what we're going to do is we're going to get requirement file, requirements.file. This is a standard practice where you want to keep track of all the packages that you want to use for your software. So you can, in the later stage, if you want to install your software and you want to figure out what are the libraries that I use for this software with my Python applications, you can just list down all of them to requirement.txt and use them. So we're gonna list down Pytest here. And next thing is we're gonna create a file. Let's call it app under test underscore app. Okay, so this is one of the nice feature of wait, what was the one of the nice feature of a PyCharm that it automatically install all the libraries that you want to install. So we are, okay, I think I made a typo. Okay, let me increase the size of, I always forget that how to like editor. Control plus plus, Control C plus plus. Oh no, this was like just, okay. So I hope you guys can see the code that I'm writing here. Hopefully is visible. Okay, so first thing first, let's write some simple test. So def test, let's say add, and assert 2 plus 1 equal to 3. So this is a simple testing code. You can see there is nothing fancy going on here. Now in my terminal, I'm gonna run the test. So simple pytest, and after pytest you write your file name test app.py, and you just press enter and it says passed. So this is how you normally run your testing code. You say pytest and then test.py. Now one of the example, one of the thing that we do often do in our testing is we have some method and we want to test that this method raise the assertion or raise the, basically raise the error. A lot of times you have a code where you just if something goes wrong, you want to make sure that my method is properly written to raise the error. So how you verify that? How you write the test that my method raise certain exception properly? So let's do that one. So basically, because it's a PyTest, what we're going to use is pytest.raise, which verify that the certain exception is raised properly. And so def test divide by 0, and with PyTest. So here we are using some of the PyTest functionality. So we need to import PyTest here. .raises. So pytest.raises, basically here you can verify that, hey, it verifies that the certain exception is properly raised. And which exception is raised, you can either write the general exception, or in our case we are arithmetic error. This is 0, b is an error. And then you can say 1 divided by 0. Okay, so let's do without this. Let's just do this 1 divided by 0. Assert. We don't need to do anything. Just 1 divided by 0, and let's run this and see what comes out. So if you see here, it created an error because 1 divided by 0, of course, is raising an error. So actually, your test failed here. Your test failed here, right? Now you want to make sure that your test pass, and basically your test case makes sure that the appropriate SSN has been raised. So with Pytest, we can do that. Or if you want to see some proper method, you can say that def divide a comma b. This is just the purpose for the purpose of testing our functionality, a divided by b. So you want to test that test divide 0, and let's say test divide POS for the sake of positivity, and we say that assert 4, 2 equal to 2, and then we do this. So this makes sure that return. So this is the method that you want to test, and we know that if you by default when you say divide divide by 0, 1 divided by 0 is gonna fail. So assert. So here we are calling the method 1 divided by 0, and here we are calling method. So if you see here, we are testing the method that, hey, it works well, but when there is a divide by 0, I want to make sure that the essence is. So if you run here, so all of them run fine. So basically, we know that when you are dividing by 0, it take care of this scenario properly. This will be very useful when you're writing a test and you want to make sure that your method raise certain exception properly. So this is the normal how we use Pytest and how we work with the Pytest. Now let's look at the parameterizing the Pytest. So if you remember when we're talking parameterizing, basically, if I have to, let's say, if I have to, let's say, this example, calculator, if I want to test on different input, I have to write 4 times assertion and write all the possible cases. Instead of that, what I can do is I can pass all my parameters and then just write one experiment, and all my values will be passed through this. So instead of writing this 4 statement, I can pass all this as a parameter, and I can just write one statement, and that one statement will take care of the whole thing. So so here, if you see the example here, we are using Pytest because we need to use this parameterize decorator here. So how this decorator basically works. So Pytest mark parameterize on top of the testing method on which you want to parameterize. Then so first thing is you're gonna this will have like opening closing bracket, and there are 2 parameters that you pass in your opening closing bracket. First parameter will have all the list of inputs or parameters that you want to give into your method separated by comma. So if you see input and expected are acting as a single string in the opening closing bracket, and this input and this expected, so input and expected are pointed out here. There's a small typo here. So this test underscore input supposed to be only input. So just sorry, I forgot to fix that. So input comma expected will be you type here input and expected, and then the second part is where you pass all your list of values. So this is the list. Inside the list, you are passing set of tuples, and each tuples is basically value associated with the input and expected. So in the list has 3 elements. That means you are passing three cases, 3 scenario that you want to test. For each of this scenario, for each of this scenario, there is a tuple, and inside this tuple, you are, because there is only 2 input here or 2 parameter here, input and expected, you are passing 2 things here. So 3 plus 5 will be your input, and 8 will be your expected. So this is how the mapping happens. So what this will do, so first thing, it knows that there is the input and expected, and this input and expected, you have to exactly what to type here, you have to type here as a parameter for the method. And then with the parameterize, within the list and with each of these tuple. So in the first run, it will take the first tuple, take the first element in your tuple, assign it to your first parameter in your input, take the second tuple and pass it second parameter. And let's say you have input comma, let's say random variable comma expected. If you had three variable here separated by comma, you could have three, you had to have three parameter here, and you could have tuple of three elements here. So this is how the whole mapping happens. The number of the number of parameter or number of variable that you define here as a single string separated by comma will has to match the number of tuples that you create within the list, will has to match the the number of parameters that you create here. And finally, this t plus 5 and 8 will be passed in here, will be tested, works. I mean, if it pass or fail, we will see the answer. And likewise, so basically this is how you can instead of writing the three statement here, you can just write one statement and pass all the other thing as a parameter. This is very useful when you have different kind of scenarios and you want to see how in different scenarios things work. So this is a very simple example, but I have seen this happen in complex scenarios also. This could be, let's say, lot of time, let's say you're making certain HTTP calls and you want to see the response. Is it 404? Is it a 202? Is it a 200? And like you can pass all these request URI and stuff like that and see capture the answer. So there are so many things you can do with this. Now this is the second scenario. Let's say so here we are passing exact matching. Let's say you have two variables and you want to pass like combination of each of them. So zero should be, so x of 0, y of 2, x of 0, y of 3, x of 1, y of 2, x of 1, y of 3. If you are into some kind of this scenario, you can do like this. You can pass two of parameterize and combination of x and y will be passed on. So instead of just passing on two scenarios, this will basically pass four scenario. 0 with 2, 0 with 3, 1 with 2, 1 with 3. So these are the two ways you can do the parameterize. So let's go back and work on this example. Okay, so parameterize. So we already have Pytest installed, so there is no need to worry about that. Let's say def execute statement, just a random name. Let's call input and output. So what we're gonna do is equal to output. Let's call it output. So basically what we're trying to do here, sorry, eval. So eval is basically to evaluate the statement that we are passing here as a string. So basically what we're trying to do here is we want to check the input and output match. And now for each input and output, we want to pass different scenarios or different use case. What will be the input and what will be the output? So we start with pytest dot mark. So you will see this a lot dot mark, which is basically, that's how the whole thing is structured. And then parameterize. Now within the parameterized, so two things. So in the parameterized, you're gonna have two sections. First section is for the the number of input. So so here, since we have input and output, we're gonna call it input comma output. So that is the first part where you define the variables or the parameters that you want to pass into your method, in this particular method that will go in the loop. In the second part here, where you basically define the list. This list will have elements in tuples, and because there are two input and output, we're gonna have two of them. So this is the this is for the input and this is for the output. And because this is eval, we pass things in string. Sorry, I just need to quick referring my things. Anyways, so if you see here, let's just change input v. This is so it doesn't interfere with the system variable input, because input is also the way to read the string. It's a by default Python method. So just to not mess up the by default Python framework, we're just gonna call it input v. So input v and output. So this is the input with output. So this is just a single statement. So now let's run this whole thing. If you see here, we only ran 3 tests. And if you see here, we previously also ran the 3 tests. Why? Can you quickly type why this one was not executed right now? Quickly, anyone can type and tell me. So pop quiz. So we ran the test. There are total 4 testing method here, but it only ran 3. It didn't run this one. Okay, because we didn't write this one. Pytest will not recognize unless you write test underscore. So because of that, it didn't run. Cool. So let's run this again. And now you can see here we ran the 4 test. Awesome. So now if you see here, now there's something called V, which is called verbose mode. So with that, what you can do is you can have verbose output, which is it tell you much more about the test. So if you see here, it just say 4 dots, doesn't tell anything about the test. But if you see dash V, and when you run, so you can see here there is much more information around here. And if you see here, when you are running this parameterized test, it is telling you what was the parameter being passed. Now let's pass a couple of more parameters. Let's do 4 divided by 2 because I like it, and the answer is 2. Let's run it again. So if you see here now, for the single we had 2 parameters, so we can see as a 2. So this is how you can you can parameterize your methods, and you have only single eval statement. If it's a calculator, it could have been only single calc, and then all the inputs going on here, and you are checking different kind of outputs. So this is a simple example. Now let's look at this parameterized x and y thing. So what could be the good example? So right now, okay, first let's def test cross params x comma y and parameterize and x comma, let's say it has values 2 and 3. Now if you see here we passed tuple, but since there's only one x, so we are not passing any tuple. We are just saying, pytest dot mark dot parameterize y, and let's say 4,5. I don't have any specific thing here. So what I'm going to do is just to see that this works, assert type of x equal to type of y. Now let's run the whole thing again. So if you can see here, with the x and y, if you look at the parameters, so 4 and 5, 2, 3, and 2, 3. So basically it is using 4 with the, so because start from here. So take a 4, then with 2, take a 4 with the 3, then take a 5 with the 2, take a 5 with the 3. So that you can see that there are like 4 tests here instead of only 2. So this is how the cross testing work. If you want to like mix up the parameter and usually use the combination of all the parameters and see the output. Now if you can see here, in all this testing, we are testing everything. But let's say we don't want to test everything. We just want to test that one particular test and not all of them. So how you can do that? So to do that, there is this parameter called desc. After desc, you can use, let's say cross as a keyword. So you can use the keyword and it will filter out all the tests that are like, that contain that cross keyword as a part of their name, and then only run those tests and not all. And I'm just gonna do desc, so we keep getting the verbose mode. So if you see here, the only test which has cross was the final test. So here it says that collected 9 tests, but deselected 5 and only selected 4. So this is how using desc k, and then after desc k passing certain keywords, it will only use those keywords to actually run the test. So this is one of the way you can filter the test and only run the selected test. Or sometimes if you just want to run one test, you can just say like, so let's say I just want to run test divide by 0. So you can just say, okay, just do one thing. A lot of times when you're debugging, oh, sorry. Many of the times that will happen if you're writing a code and that one test is failing and you're trying to fix that one test, and how to run just one test. So this is how you just run the one test and debug and figure out. So desc k for filtering test and running only subset of test. So this is how the parameterized thing work. Now let's go to one more feature called skip and fail. So when you are maintaining a big software system, and oftentimes what happens is, let's say some bug appears, and a lot of times if you have seen the, so normally software system uses something called the continuous integration, continuous deployment. Continuous integration is every time you submit the code, it will try to test the code, and if testing pass, then only submit. And if something failed, then like basically do not deploy the code. Now let's say because of some kind of testing failure, you're not able to deploy the code because you have this pipeline. And what you can do is in your test code, there's this one test which is basically causing the problem. So what you can do is you can just mark that as a skip. So every time you're running your whole test suite in your deployment environment, in your continuous deployment pipeline, it will not block. It will say that, hey, this we are skipping this for temporary purpose, and in future we're gonna fix that. So this is very useful. Or sometime you have this bug and you say that hey, there is no test to fix this bug, or something is causing a problem and you have to fix that. So you say that, hey, I'm going to write this test and I'm going to skip for now, and in future it's going to keep running. So in so many cases, so many times that happens, that some tests which are working fine and now they're failing, and because they're failing, you're not able to, your whole deployment pipeline is blocked. And because until you resolve the problem, it cannot be fixed. So instead of like waiting to getting your test fixed, and you never want to delete your test because it's failing. If test is failing, that is the main reason you want to keep the test. So you don't want to never delete test that is actually failing, because that says that something is going wrong, something is going unexpected. But still you want to go ahead with that. So what you can do is you can mark them as a skip or fail. Skip will basically not run them, and fail will expect that, hey, I'm gonna run this test, but it's gonna fail, basically. So these are very useful scenarios. Sometimes your test was working fine, but now it is failing because let's say your testing environment had changed. Let's say you wrote some kind of functionality that only work in that was deprecated now. Let's say you wrote some kind of a method, some function which was like part of Python 2.5, but now all your environment has upgraded to Python 3.6, and that 2.5 is no longer valid. And because environment has changed, now your test is failing because the test is now run on Python 3.6, and your method is using these deprecated, unavailable older methods. So those kind of scenarios comes in, and then you wanna like, hey, I don't want to delete the test, I want to fix the test, but right now I cannot spend time fixing this. I need to get things going, so I'm gonna mark this test as a like skip if I'm testing on this scenario. So all these possibilities are there. When for any reason you want to skip the test, you can use this kind of facilities. So this is something that is available in Pytest and not Unittest. So something that to know about when you're using Pytest. Now let's go to fixtures. Now this is the most important topic or most useful thing in Pytest, and used a lot, especially in the functional test. So just to remind, we have something called unit test, integration test, and functional test. Unit test basically is all about just making sure that one method, one function, that one business logic that you wrote is working fine. And normally when you're writing unit test, you don't talk to database, You don't, uh, um, you don't talk to database, you don't talk to any kind of other system, because you assume that you are unit testing the methodology, and that doesn't talk to anything. It's just single independent component, and not the component that talk to different kind of systems. So that's a unit test. And you use mocking when there is some kind of communication going on, to mock those kind of things. So mocking we'll cover sometime later. So that's the unit test, just checking single function method independently. Second is integration test, which test or make sure that things are playing well with integration. So let's say you have a logic or service, which what it does is it stores data and read the data. Now sometimes when you're storing data, you do some kind of formatting. When you're reading the data, you do some kind of formatting, or you want to make sure that there is no backward compatibility breaking. So you put some kind of Traferet. Traferet is a way to verify the schema of your data or thing that you're reading from database. So when you're putting all this kind of reading and writing kind of scenario, or when you're communicating, so all kind of testing that makes sure that all those communication are moving smoothly, all those communication with database, communication with different services are working fine. So that's integration test. And finally, functional test. Functional test is most important part, because in functional test, you have your whole enterprise software up, running, working, and then you test it as an outside user. So let's say you have a system of payroll. So when you're doing functional test, you are actually running all the system, all the component, everything. If there are 30 services, you start 30 services. If there's a database, you start database. If there's a Docker, you start Docker. You get your app up and running as in a phase that you can literally use the app, and then you start testing as an external tester. So that's the functional test, where you are not, it's a more of a like a black box testing. You're not testing how certain things work. You are testing that things work, things are behaving the way it is expected to behave. That's the functional test. And one of the major part in functional test is you have to create, so let's say you have this payroll design, you have to check that, hey, I want to verify that my admin can let's say delete user. So for that, what you have to do, just to test that my admin can delete the user, you have to first create the admin, you have to create the user, you create the two user, you make one user an admin, and then after doing all that, you finally run that test which says that, hey, now my user one can delete the user two. So if you see that the whole part where you create the admin, you create the user, and all the setting up the app and everything, you don't want to keep doing that for each. So let's say you want to check, hey, can admin add the user? Can admin delete the user? Can admin modify the user? Can admin change the name of the user? You don't want to like every time create the app, create the user, and verify one functionality, then delete everything. Again, create the app, again, create the users, again, assign the roles, and then verify the second this add functionality. Do all those things again. So doing all this over and over time is expensive, because this is very expensive way to testing functionalities. So what you can do is, instead of that, you can create the fixture. Inside the fixture, you can set up all those kind of initial bare metal environment, you can say a state or environmental services, and then you can write the test. And when you're writing the test, you just call the fixture. So if you see here, so let's see the example that we have on the screen. So first thing is pytest.fixture. This is the this tells that this method going to behave as a fixture, and this method is actually going to have all the setting up things going on. So here we are setting up this SMTP connection. So to set up the fixture, we are creating this SMTP connection here with the SMTP library, SMTP protocol, the server address, the port number, timeout, and everything. So here you are creating the resource. Here you are creating some kind of setup, some kind of environment, and then you are testing that, hey, this particular connection is working good. So testing extended. So this is the we are testing basically that extended SMTP server connection working fine. Test hello, extended hello. So here we are passing SMTP connection. So when you say test hello SMTP connection, so SMTP connection is a fixture, and before it start testing test hello, it will go to SMTP connection and make sure this fixture is up and running. So it get all this fixture to up and running, and finally the output of this fixture is basically this handler, and then you use that handler to do the testing. Now, by default, when you say Pytest or fixture, it's gonna behave like a typical unit test test unit. Basically, every time you have a fixture, you're calling the fixture, it's gonna set up the fixture and use the fixture. So basically, if you have, let's say, test hello 1 2 3, so 3 times it's gonna call the fixture, create the fixture, and then 3 times it's gonna like create this resource and then assign the resource. So that is the default behavior of the fixture. So we will see how we can fix that, and how we can have only one fixture for all the 3 scenarios that we'll see next. But just to say that default behavior is for every method, when you're calling the fixture, it's gonna create the fixture again and like, gonna call the fixture again. Now let's say what you also want to like tear down. So how you create the fixture and make sure that once it is being used, it get tear down. In the unit test, we had setup and tear down method, but here we don't have setup tear down. It's just fixture. So the way to do it is when you create the fixture, see the second scenario. When you create the fixture and whatever you're supposed to return, whatever handler you're supposed to return, you yield the handler. If you remember, yield is coming out of more of a iterator world, or like, when you ask for next thing in iterate basically. So when you say yield, when it comes to yield statement, it just, let's say, it stop its state here. Every time you see yield, whatever it yield, it stop there, stop executing there, and whatever statement it's supposed to yield, it yield as a return statement. So when you say SMTP connection, we're supposed to return something. So what it will return, anything that is written after yield. So SMTP's connection is called, it will execute up until the yield statement, and whatever is after yield will be given to this particular method, and it will stop here. It will not go after yield until and unless this thing is called again. So basically everything. So what you can do is here this fixture is called. So yield will give the handler to this method, and then after yield, whatever statement printed will be executed after the SMTP connection. This handler is done. So after whatever you want to write as a tear down, you write everything after yield statement. So simply how to do the tear down. So this is your statement which doesn't has any tear down setup. So whatever you're returning, instead of return, you say yield, and whatever you're returning, so yield and whatever you're returning, and finally after yield, you write everything that you want to have executed as a tear down. So when the SMTP will be done, it will execute all these things. We have less time, so I'm gonna go through all the theory, and then we'll see what we can print in our pipeline. So here we see how the fixture works, and this is a default fixture because there is nothing we are doing here special. So that means for every test call, it will recreate the fixture. So how to fix that? So you can pass something called scope as a parameter to the fixture, and you have different scope. And what are different scope? First is the functional scope. Function is the default scope basically. When you're not passing anything, it's a basically function, which says that destroy the fixture after the test is done. So in here, this scenario, once this test is done, destroy the fixture. If there's a tear down statement, run the tear down statement. Otherwise, it's done. So this is function. This is what we are seeing here. Without nothing is equivalent to scope equal to function. Now there's a scope equal to class. So what you want to do is you have all this test method written inside the class, and you want to keep the fixture up until single class. So you can create the fixture, keep until the class, and do all that. And then for the module, package, and session. Session is basically create the fixture and keep it up until you're done with the whole thing. Like you're done with the running all the tests. So that is like till the session. Package and module is for basically, module is basically for the file, because normally we see file as a module. So let's say, this fixture has to stay up until this particular file is up, or we are done executing this file. So that's the module. Now, fixture has its small problem. So this sounds good when you are trying to, the scenario where you want to check all the functionalities that particular, admin user want to do, because you just create the one fixture once. You just create account one, you create user one, and then you just do your all, you do all the processing, all the testing in the single account, without creating the user all the time. Now, what problem it can cause? So it can have some kind of effect, so let's say you have this admin account, and it ran this first test, and that led some side effect. Let's say your first test was add user. So when you say add user, it creates the side effect that now that fixture is holding this particular session has this extra user being created from test one. And now you're going to test two. And this test two will have that user from the previous test because your session, your fixture is still up. So many times many times what you can do is that you can run certain functions in parallel. So let's say you are running all these functional tests in parallel with multiple files. You have this single fixture and one is adding, one is deleting, and like, it can create very weird scenario because of the race condition. So these are something that you want to be aware of when you're using the fixture, that uh, fixture is like, when you're using fixture and there is a there are always a side effect being left by multiple methods, multiple testing, because you're doing something and uh, you want to be conscious about how you set the level of your fixture. Let's say you're testing one functionality and you think that there's no issue running them in parallel, so you can just create the fixture in one module that only tests one feature and not on the session. So for different module you can have different fixture, although they're doing the same thing, they're again creating the same account, but the idea is you don't create this kind of scenario where there are some side effect and it kind of creates some kind of flaky or weird test, sometime pass, sometime fail, because of how the previous test left the particular session that it created in that particular fixture. So that is just one thing that we need to be like careful about. I think we have a couple of minutes, so I'll just quickly try to do this one example and do with that. So let's just create another. Okay, let's just do this. It's fine. Okay, so first thing first, we want to create something that is a fixture. So def. Let's do the same example. I hope my SMTP import. Let me see if import SMTP. Okay, it's there. So let's say SMTP connection, and this should connection equal to SMTP lib dot SMTP, and then let's say email.gmail.com 554, I think, and let's just do that much. That should be okay. 587, sorry, 5. These ports are and smtp.gmail. Yeah, smtp.gmail. So this is our so this is the method. We want to use it as a fixture, so we're going to call it pytest dot fixture. So we are not going to do any scoping thing right now. So now what we want to do is this would be yield, and this would yield connection, and after yield connection dot close, because you always want to close the connection. And then now let's try the test, test SMTP, and we're gonna call SMTP connection here. And what we're gonna do is assert SMTP con dot so there is this method called hello, which is basically extended hello, extended SMTP thing. So this is a method that we wrote here, and for the purpose of this one, we'll say print closing. Let's run this thing. Pytest test app.py, and that's v for verbose mode. Plus, we're gonna only run this particular test, so we're gonna call SMTP. And what else? Let's run this. So say it says passed. Now there's this thing that I think it was a parameter des s that will print yes. So des s. So normally when you run your test, if you are printing something within your test, it will not be printed. until it fails. So it will, so basically it will only print if something fail. So let's say I just do asset false, and then I do this. So when it failed, then it says that this is the capture as std out. But let's say if I don't do this, and if I just run the whole thing, it will pass and it will not print anything. So, and there is another workaround is if you want to print something, you can pass something called dash s. So dash s parameter will print anything that is being printed, and that way, like if you're printing something, you will see in an output. So closing you can see as an output. So if you see here, this is how things work. So let's go back to our presentation and go to the closing. So as you can see here, that Pytest is more powerful because you can do parameterizing, you can do, different kind of parameters that you can pass. You can skip things. You can run the subtest of test. You can, fixtures are there that can do different kind of magic things, and there's a different scope in fixture that can help you with a lot of things. And this is just a very small or the core functionality. There are so many other things that you can do with this, but this is something I thought very essential for everyone to know about if they're using Pytest. So this is what I covered. And of course, one of the thing is you can write less. You need to write less code with this, and it's also very powerful to execute. So that's all. Thank you very much. So a lot of the code that you saw in the presentation are picked up from their official page. So that's for the plagiarism, I would say. Anyways, so thank you very much, and thank you for joining me today. That was it, and in the next session we'll try to cover more things. Last housekeeping things. So all the presentation will be posted on our Meetup page. You will see the recording. You will see this PPT link. We also have a GitHub page where we put all the code and everything. So you can also go and check it out there. Which will also add all the links to presentation and our recorded video. And if any of you are interested in presenting in one of those upcoming meetups, let me know. I'm open for people to come in and basically present things. If you see here, this is all very elementary basics. So if you're learning something, you can also do that. If you're learning something last week and you want to present it next weekend, we can plan something like that. So don't be intimidated by you have to be master with these things. If you know enough things, you can present, and we are all learners here. So we welcome all of you to be part of it. And Adam, do you have any question? I see you have raised your hand. Sorry, I was so much involved in presentation, I didn't listen. Adam, you can unmute yourself and speak if you want to.
Anyway, thanks, Nishant.
Okay, cool. Yeah, thank you, Charlie. Thank you, everyone who came here. And yeah, reach out to me if you have any questions, and ask me for any other help you might need in your Python journey. Thank you all. Have a good night.
You too.
Bye.